Okay, the goal in this problem is to draw a Lewis structure for ammonia, NH3. Go ahead and pause the video, follow these directions, and give it a try. Okay, let's walk through it. So the first thing I need to do is I need to compare their electronegativities. Now, without actually looking them up, I know that nitrogen is going to be higher in electronegativity than hydrogen. Now, if I actually want to know them, I can pull them up like this. Okay, so for nitrogen you can see electronegativity is 3.04, and you can see also that for hydrogen it's going to be our, well, this says 2.2, we're used to seeing 2.1, so you're going to see different values from different places, and that's fine. So let's come back over. We've determined our electronegativities. Nitrogen is the big one. That means nitrogen doesn't go in the middle, except hydrogen can never be in the middle. Since the only remaining atom is nitrogen, we have to draw nitrogen as being in the center. I'll go ahead and I'll put my hydrogens around it. Okay, now I have to sum up the number of valence electrons. Nitrogen is going to have 5 valence electrons. Hydrogen has 1 times 3 for each of the atoms that are there. So I'll have 5 times 1. That'll give me 5 plus 3 gives me 8 electrons to work with. So I'm going to use that 8 electrons. Here we are, 8 electrons. Now we're going to draw a single bond between each of the atoms to start. We have 1, 2, 3. That means I used up 6 electrons. 2, 4, 6. I have 2 remaining electrons to draw in. These are now full. Hydrogen has 2 with its sharing. Same here, same here. The remaining pair will go on to nitrogen. We finally fill the middle as our last ditch effort. And then we're going to check our octets. Hydrogen caps out at a duet, so it's full. Same with all of the others. Now this nitrogen has 2, 4, 6, 8. Its octet rule is filled. And so this will be our structure for ammonia in terms of Lewis structures. Now for three-dimensional structures, things are going to be more complicated than that. Now the last thing we're going to do is our double check. We did see that everything has an octet. We did not have a charge at the beginning, so we don't need to double check that there's a charge that we need to show. And that would be how we'd solve a problem like this one.